So one of the projects that we've taken on over this quarantine is fixing up and making a garden. Now, one of the things we wanted to do was set up some drip irrigation, and we had some of these drippers laying around, and instead of ordering more, I wanted to try to 3D print them. Now, these are pretty common, pretty basic. Water comes in on the barbed side, high pressure from usually a garden hose or something like that, and low pressure comes out on the other side, usually or half a gallon per hour, something like that, with different amounts depending upon your scenario and what you're looking for. And this is just a slip side, so if you wanted to slide a tube on it, you could. Now, I was curious how this worked, and what I found was actually really fascinating. In fact, what's interesting is that this is actually made up of 3 parts, and it was really hard to get one, so I have a broken one down here. Now, I took a pair of cutters to it and then a hammer and finally got it to break apart. It turns out there's 3 parts. This part broke, of course. And what's kind of neat is, so you got this one half and the other half, and this is the side with the low pressure side, and the other side is the high pressure side. And inside of it is this disc. Now, what's interesting about this design is that you can see how it was made for manufacture. So you have an injection molded part here, probably ABS, which if you look at the other one, you can even see, come on, focus. You could even see how there's a part line there. Come on. There we go. You might be able to see there's a part line there, and there's a little bit from where either the mold came in or a sprue or something like that. The other one, the part line's a little harder to see, but in any case, 2 injection molded pieces on the outside of them fused together. On the inside, you have this disc. Now, this disc is made out of some sort of like gasket-like material, and what's kind of neat is the way that it works, right? So you have high pressure on one side, low pressure on the other. Now, water would come into this side, go through this channel, through all of these things out here, these convolutions, essentially building kind of like a resistor, but for water, then go through a little hole to an identical side that now essentially does these things in reverse. It goes around the outside through the center, and here you go. What I thought was really clever is that this means that you can have one manufacturing process for this, one for the other side, and then you could have this where I don't have other capacity drippers, so I'm not sure how they're different, but I imagine they're just either different stiffness material, different size channels, something like that in order to do that. But what you get is the water pressure will, 1, push this against the output side, sealing it with the greater pressure, sealing it more. I imagine that deforms it a certain amount. You also basically have in an electrical sense, a resistor, because every tube, every conduit has a certain resistance to flow. And you're just taking advantage of that here with this. I mean, the symbol for a resistor in a diagram is a squiggly line here, because even wires have a certain resistance to them, and the different gauges of wire, based on the amount of current you're passing through them, actually do have some voltage drop on them, have a resistance. Now, I've tried to 3D print a few of these with varying success. This is a model that I found on Thingiverse. Come on, let's focus. Come on, you can do it. Come on. Any case, so there's a little teeny tiny hole here. You may be able to see that right here. And what I found is that when the water, this was a little too small for my tubing. I have 1/4 inch tubing. This is probably 4mm tubing. Probably just not the right same kind of stuff. The water will actually come here at really high, be just a jet. I have to look at the model again, but I'm not sure this has enough, essentially, resistance to it. So I have printed other ones, and still working on designing it. It's actually pretty challenging because I'm not really sure the variables here. But I've tried similar designs. There's probably patents and stuff on this. Rainbird or whoever it is that makes these. This is rain drip. Whatever. Probably owns a patent on it. But you can't really patent certain aspects of physics, I assume. So I'm going to work out something so that I can 3D print it. And I've had some moderate success. The ones I have that would emit from the bottom generally don't work. I think it's just too much between the bed and stuff like that. There's not a lot of precision for holes that coming out of the bottom at this size. So I'm going to make it come out of the side. And I did 2 layers of a grid in my design, where I basically had it kind of loop around. Oh, come on. Now it's sleeping. So I would have 2 different layers loop around, and that worked okay. But I think that it was a little too... Yay. Oh, it would help if I actually changed it to writing. So I did something like this, where I would have it go around, and then I would have a gallery here, an outlet here, and then this would connect to another one where it would also have, so they would be arranged like one set of stacks like this, one set of a spiral like this, so that the water would come in here, travel all the way around, go down through another tube, and then come down here through like an enlarged gallery here. And that worked in the sense of one of them blew out the wall here, and it actually worked. It started dripping, and it was still streaming a little more than I'd like, but I think, based on this, that when the water comes through a certain this part, come on, focus. There we go. So if the water comes here as a fast stream, it will attempt to fill this up, right? If this was sealed, it would fill it up pretty quickly. But the output of this is larger as far as this part is concerned. The whole diameter of this hole is larger than the inlet, which is here. So if you see that this would be the inlet into this area, please be focused. It's having trouble with this. So this would be higher pressure, but in any case, it's a smaller hole here, larger opening here, acts as, I think, like a capacitor in the electrical sense. And then this is a larger diameter opening than this guy. I think that's crucial. So this way, a stream of water shoots into here and then essentially can fall out. So I need to make sure to incorporate something like that in my next iteration of a 3D printed dripper. Now, I'm not sure if it's in part also this material, this is like a gasket material, if it does anything beyond just the fact that it's pushed in to seal, or if when it gets pressurized, if it causes these to constrict a little bit more, right? Like, I don't know how much it deforms when it's active, because if that's the case, that'd be really clever, because then as you go ahead and fill it with more pressure, these things would squeeze out and would restrict the flow even more, allowing this thing to not just drip for a small range of pressures, but to actually regulate to a pretty good extent over a larger range. But in any case, I thought this was really, really clever, really interesting, and I thought you might enjoy seeing that. So this is a dripper for drip irrigation, lessons learned there. And if I do figure out how to 3D print one, I'll be sure to share that with you.